So you often say also create Flintstone designs. Can you elaborate on this philosophy and then also explain how simplicity and robustness contribute to more effective and resilient structures?
Sure. Well, you're a young lady. Do you remember the Flintstones? Maybe not.
Absolutely. No, I
Okay.
absolutely do.
Okay. There was the two Flintstones were Fred and Barney, and they led a very simplistic life. I'm not so sure there was an episode where they invented the wheel or something, but it was very simple. And their approach is one of the best design approaches that we have. And it's symbolized by many people called KISS. Keep it simple, stupid. You need to keep things simple.
Fun fact, 60% of construction project failures are linked to poor constructability. For structural engineers, this challenge highlights the need to design projects that are not just innovative, but practical and buildable. In today's episode, I'm joined by Dr. James Fisher, a Ph.D., a P.E., and a distinguished member of ASCE. James is a consulting engineer at the Steel Joist Institute and vice president of CSD Structural Engineers. Dr. Fisher brings decades of experience and expertise to the table as we dive into the core principles of successful structural engineering. We'll uncover how simplicity in design, attention to detail, and effective collaboration can transform projects by reducing costs, meeting timelines, and ensuring lasting quality. I'm your host, Rachel Holland, and this is the Structural Engineering Channel.
This episode of the Structural Engineering Channel is brought to you by PPI, a leader in engineering exam prep for the PE structural exam. PPI provides expert prep courses and study resources designed to help you pass the PE structural exam the first time. PPI's PE structural course is fully updated and taught with October 2021 code references and includes new editions of their PE structural books. PPI's live online courses include hours of lectures, problem-solving demonstrations, exam strategy sessions, office hours, and a passing guarantee. When you take a live online course, PPI guarantees you will pass, or you can take the on-demand course for free. PPI has helped engineers achieve their licensing goals since 1975. Check out PPI today at PPI2pass.com to see all of the resources available for PE structural exam prep. Again, that's PPI2pass.com.
James, thank you for joining us today on the podcast. We'd love to hear a little bit about your remarkable career in structural engineering, and also, when looking back, what initially sparked your interest in this field and what pivotal moments shaped your journey?
Okay. Well, originally I thought I'd like to be an architect, but I lived in Wisconsin, and the University of Wisconsin did not have a school of architecture. So I decided upon civil engineering because my father had been a civil engineer. And I had some really good professors at Wisconsin as an undergraduate. To name them, Charles Salmon, C.K. Wong, and one instructor in particular, a gentleman named Don Bittner. So they guided me sort of into structural engineering. I was impressed with all of them. After Wisconsin, I went into the Army as a combat engineer for 2 years. And at that time, I decided I'd really like to teach at the university level. So I went to graduate school at the University of Illinois in Champaign-Urbana to get my Ph.D. Right after that, I started teaching at the University of Wisconsin in Milwaukee. While teaching at UWM, I went to a technical meeting, ASCE, and I met a gentleman named Dr. Galambos, who's well known in the structural engineering profession, at least by the older folks, okay? He's one of the icons. And Dr. Galambos pointed at me and he hit me in the chest and he said, "You young man, get involved with professional activities." And that was the first action that really got to me as to what I should do as well as, teach. So then I taught for 5 years and decided that I liked consulting better and left the university to join a firm that I helped start called the CSD Structural Engineers. And it was then really after that period of time I became very active in professional societies as well.
Excellent. And your work with the organizations like Steel Joist Institute and the American Institute of Steel Construction, those have significantly impacted the industry. So, what have been some of the most rewarding aspects of your involvement in those
Hmm.
industry?
Yeah, well, there's a lot of rewards there. I think the key word in the question is knowledge sharing that I learned. Getting to know the leaders in structural steel design and in joist design was invaluable to me. That way you could really learn. And I learned from a lot of these folks in these organizations, and I hope they learned a little bit from me too. And then you have an impact on the building codes in those organizations, and that was quite rewarding. But I'll tell you, by far, the best part of my involvement with professional organizations was the development of many lifelong friends. These are my best friends, and it was very rewarding to not only work with them, but to socialize with many of these individuals.
Yeah, that's a great positive reward for those types of involvement. I also feel like our industry just as a whole is, I mean, you said knowledge sharing, but yeah, the collaboration that's just required to continuously make us better at what we're doing, and that's something that I'm a big fan of as well.
Sure,
So,
it's like when you go to a conference or a meeting, it's the after the lectures and the conversations you have, which you learn the most. So
yeah,
that's
definitely.
that's very rewarding.
So thinking about constructability from the very beginning, that's a key advice that you tend to share with engineers. So why is the principle so important and how can it prevent costly issues in the design process?
Okay, I think maybe first for some of the folks who may have to define constructability,
Okay.
uh, it really is the extent to which the design of a facility provides for ease of construction. You need to be think about how the building is going to be constructed. Our jobs as structural engineers or design engineers is to produce construction documents in order to build a structure. That's our job. Construction documents to build a structure. There's too many engineers that emphasize analysis and calculations. These are certainly but a means to the goal of constructing a building. So one needs to think about constructability at all times and don't get hung up on how you get to how you get there, but create nice and clear plans.
Right. So is that something that you would like kind of really emphasize when you were a professor, or was that later on when you were doing all of your industry work? And like when you say prevent costly issues, like what dive into that a little bit more. I mean,
Okay.
I see them every day.
Yeah.
But
Um,
yeah, what are you
I,
referring
I
to? Give some
I'm not
examples.
sure too many professors emphasize constructability. They
Okay.
have limited amount of time, but I think more and more it's well. My philosophy is that professors should teach students how to think. We as the consulting engineers should teach them how to design. And when you teach him how to design, him or her, you get into things like constructability more than you would in college.
Definitely. So you often say also create Flintstone designs. Can you elaborate on this philosophy and then also explain how simplicity and robustness contribute to more effective and resilient structures?
Sure. Well, you're a young lady. Do you remember the Flintstones? Maybe not.
Absolutely. No, I
Okay.
absolutely do.
Okay. There was two Flintstones were Fred and Barney, and they led a very simplistic life. I'm not so sure there was an episode where they invented the wheel or something, but it was very simple. And their approach is one of the best design approaches that we have. And it's symbolized by many people called KISS. Keep it simple, stupid. You need to keep things simple. Uh, Engineers need to remember that there's going to be some poor soul or souls out there in the blazing heat of the day trying to build this structure or in the freezing temperatures. And the last thing those constructors need is complexity. They want it to go up easily. Again, that's constructability. And I think that's what's key in the Fred Barney quotation.
Yeah, that's very true. I mean, I get involved in things more on the connector side of things. And I can say just from experience that having engineers put on their plans, the same type of strap, for example, that will cover all their loads versus trying to be selective on where they put them, might
Hmm.
save a little bit of money, but in the field, it just makes it a lot more complicated for the individual
Yeah.
that's installing it.
I didn't realize you are an engineer, but
Oh, yeah.
one of the things that engineers need to think about very first in their design is what are the connections going to be like? Because that can dictate member sizes. It can dictate a lot of things. So good point. I'm glad you brought that up.
Yeah, yeah, yeah. So, okay, so another question for you. When you think about balancing tradition and innovation and the recurring challenges of balancing those in engineering, how can engineers decide when to stick with proven solutions and then when should we be exploring new approaches?
Okay, I think that I can shorten that statement fairly quickly. When I was in the Army, there was an old saying, if it works, don't mess with it. And that's true. If something works, be careful about messing with it. Uh, it's good advice, but we still need to be open to new ideas, new methods. But the key is that we need to examine those very carefully, our knowledge and basic principles we learned in school. So I think that's key. But yes, we need to be open, but just don't jump into things if you haven't really studied it.
Yeah. It's interesting too, like that, the thoughts behind that, just because as we, progress in life, we're learning so much about like, I'm West Coast. So much of it is
Mhm.
like seismic engineering. And,
Right.
you know, as tools advance and things like that, and we can capture data more and find out more things, like the whole industry is progressing. So it's an interesting balance that we have to figure out.
Yeah. And one thing that's happened, I've noticed it a little bit when I was teaching, but even more so, like Excel spreadsheets that engineers all write, and then they do a graph. And today, so many people spend more time on making their graphs pretty rather than analyzing the data in the graph. And I think that's something we should think about more than we do.
Okay, another thing that you've cautioned against, worshiping the weight god.
Yes.
Can you talk a little bit about what you mean by that and what that is?
Yeah. So it kind of goes back, I think, to a previous comment you made. The American Institute of Steel Construction for many, many years has stated least weight is not least cost. Unfortunately, that doesn't stick with many folks involved in the construction industry. The final cost of a structure, steel structure, let's talk about, depends not only on the amount of material, but it depends on uh, labor costs. And the labor can be done cost in detailing time. You kind of mentioned that with connections. Detailing time, the fabrication time, and the erection time. You need to think about all those things. There's been studies that show the material cost in a structural steel building is 15 to 20% of the cost. That's all, 15 to 20% of the total cost of steel. So the rest is in detailing and erection and fabrication. So least weight, engineers get so hung up on the least weight, may not be the least cost for the structure, and usually is not.
Interesting. So, how do you strike that balance? What's your approach?
Um, I would say to analyze the structure and think about the constructability, but then also take a look at your computer output and make sure that everything is organized in a way where you've got duplication. Duplication is key for the person designing the connections. It's key for the fabricator. He only has to deal with one kind of item, and it's key for the erector. So I think about that, right away. Uh, I found years ago that if you make lots of different kinds of details on a plan, the erector may look at the first one and think that's where it is everywhere and screw up. So the repeatability is very key.
Yeah, definitely. What about when it comes to paying attention to detail and how critical that is and having small errors cascade into a major issue? There's a caution that you give. You say you cannot just do one stupid thing in the design. Do you want to talk a little bit about that and
Yes.
how that's been come up in your
Yeah.
career?
Yeah. Actually, I have some great pictures that I want to share at some point with the viewer.
Perfect.
There was a building being built, and whoever decided on this particular beam was a very big concrete beam. And the reinforcement was unbelievable in this thing. And it was also intermingled with some steel. And it was a disaster. I don't know how they even poured the concrete in this thing because it was so crowded with reinforcing steel. So the problem was they must have decided right away that they wanted to use concrete beam for something. And it was the wrong choice. It should have been a steel beam where other steel beams would frame into it. So often if you get off on the wrong track, you're going to make other stupid decisions in the design process to sort of take care of the fact that you screwed up to begin with. So getting off on the right foot, you might say, is key. I tend to be a very A-type person. I like to jump into things. And one of the best lessons I learned was, again, when I was in the Army, the Captain Davis called me over and he said, Lieutenant, he said, here's a mission I want you to do. And I said, okay. He said, what are you doing now? And I said, well, I'm going to gather up my sergeants. We're going to talk about it. And then we're going to go into action. He said, no, you're not. I said, what am I supposed to do, sir? He said, you go to the mess hall. You have a cup of coffee. You think about what I've just given you as a mission and let it absorb in you for a little while before jumping into action. And I think most of us, and you may have experienced this, you go to a meeting and you make some decision in that meeting. And then you're driving home or getting off the phone or whatever, and you think, oh my God, that affects something else. And I didn't think about that in the meeting. So as we say, it's oftentimes good to sleep on these decisions, let them mull in your head. So that's what I mean by a wrong decision can affect things.
Yeah, and I think that's just a great reminder for everybody because I do think, we're in such a fast-paced world right now too that it's just like, get it done, get it done, get it done. And oftentimes it's almost a luxury to have the time to sit and think and like really put your...
Yeah. Well, things are too much driven by bankers and trying to get things built right away. I got another story I might convey that I just thought about.
Yeah.
One of my first really major design projects was a steel mill for one of the big steel producers. And I had an idea on how to save them a lot of money. And that was to design a horizontal truss system in the roof of the building, which these cranes in the building were 350-ton cranes. So they're very big. They produce very large lateral loads, more than seismic, by the way.
Yeah.
So I said, if you use these horizontal trusses in the roof, they'll distribute these crane loads to several columns, to several footings, and it'll save a lot of weight. Again, least weight. And the gentleman looked at me and he said, Jimmy said, how long will it take you to design this big truss? And I said, I don't know, it might take me a week. He said, how long do you think it's going to take the detailer? Oh, I said a week, and maybe with the connections involved too. And he said, how long do you think it'll take the detailer to detail it? I said, I don't know, maybe a week or two. And he said, and fabrication? I said, oh, probably a week or two. And he said, what about the erector? Hey, remember, this truss is going to be 100 feet in the air. So he's got to put it up there. I said, oh. So he said, Jim, if I added it up conservatively, this is going to take 6 weeks of time. I said, yes. He said, we have a $350 million loan to build this building. You've cost me $1 million just in interest by screwing around with this truss. And he said, furthermore, we'll be in business 6 weeks earlier making steel and making money. So don't use your fancy truss. Just get to the basics and get it built. And that's the big picture. That's really what we
time is
engineers,
money.
we need to think about the big picture. And so often we don't.
Right. Okay, so one more question for you. Strive for structural simplicity and don't get lost in your own technology. That was a quote of yours. And can you explain how prioritizing simplicity leads to more efficient and durable structures?
Yes, I have a picture on this one too. It's a very fancy structure. I think it's in Los Angeles. We get hung up on our own technology sometimes. And this goes back to what I said previously. We wrongly emphasize analysis and calculations. We need to, again, I think, keep in mind the keyword KISS. Keep it simple, stupid. I know that this structure and many structures like it always end up in lawsuits because they're so complicated to build and they cost far more than the contractors ever think. So I think it really needs, again, to go back to keep it simple. Again, in the analysis thing, I don't know if you heard of Hardy Cross, but he was a famous structural engineer way back. We need to study some of the old guys. He had a great saying, and I think this is really key. He said, first design the structure using your best judgment, then analyze the structure. So first design it, and then analyze the structure. If your numbers do not support your design, reevaluate your numbers. If they still don't make sense, maybe your judgment was in error. And that's a great saying, and it's been published many places where he said this. So I like to remind young people that judgment, and then young people say, "How do I get judgment?" So, well, you get judgment by making mistakes. That's one thing. You get judgment by talking to older engineers and getting their experiences, and it's something you need to really fine tune.
Yeah, and just experience helps with that gut check. Or
Yeah,
I know I've had bosses refer to it as like, does it give you a warm and fuzzy feeling? Like what your numbers,
yeah,
have
right.
led to.
Well, yeah. One of my early partners was an older engineer, and he said, if it looks good, it probably is good. If it doesn't look good, it's probably a pile of crap, is what he said.
Yeah.
So,
What about with computer, like, thinking like with all of the design tools that we have and how, we utilize those to design buildings? How do you think engineers can effectively use technology, again, while also ensuring that human judgment, the critical thinking, and those different things that we've talked about are still central in that design process?
well, we have to remember there's still tools. In my era, of course, it was the slide rule to begin with. And it was a tool. And you had to keep track in your head where the decimal point goes. The slide rules didn't tell you where the decimal point goes. So you had to know that. And I think I also sat down once over a couple of drinks with a very famous engineer, Bill LeMessurier from the East Coast. And he said, if you can't design it on the back of an envelope, you shouldn't design it. And the computer, in my mind, we've all heard the garbage in, garbage out. You have to think about your structure, what you think it's going to be. The computer can then refine your ideas. It can take 30% out of the structure or weight, let's say, if needed. And it also can check on your gut feel. So that's the way I look at computers. And I have some great sayings that we didn't have time to get into here from an older fabricator that got right to the point of the judgment issue.
Yeah. I think always just, for my early days of engineering, having managers and mentors kind of reiterate that for me. And then I feel like I've come to a point where I'm now reiterating that to younger engineers, just
Yes.
trying to really understand, like, get a feel for it, even going out to a job site and understanding like what is it that you're designing on paper and how does that translate into like a built
Yeah.
member or whatever it is. It really helps.
Excellent. That that
Yeah.
is that is so important. To a young engineer, a lot of these things are just lines on a piece of paper,
Yeah.
and it's not until you go to the job site. And I can honestly say, through my years of experience, I have yet to go to a job site where I didn't find something wrong. Now that's scary. Now a lot of them were minor things, but it's still scary. So getting to the job site and seeing these things, and again, it goes back to simplicity.
Yeah, definitely. So looking ahead, what emerging trends or challenges do you see in structural engineering? And what advice would you offer to young engineers entering the field today?
Well, I certainly don't have a crystal ball on what's coming on, but we're all talking about AI. And I don't know if you've had any involvement with AI. My understanding is, and I have not, but I've
Okay.
talked to a lot of people that it can do some marvelous things. So I think that's going to be a big challenge to all engineers, not only young engineers who will jump in and look at AI solutions. There'll be solutions for everything in AI. And the question is, are they right or aren't they right? And you, as the engineer, have to look at them because somebody's making up these solutions. The computer's not making them up.
Yeah.
You have to go back to your basic principles and look at these solutions in AI and say, yeah, that's sound. That makes sense. And oh gosh, it didn't check deflection, or something like that. It didn't check constructability. So I think that's going to be a big challenge. I think it's a big challenge for owners of firms to instill that message to the young engineers, and I think that's really important. I do have another quotation that I dearly love, and I think we're almost at the end of this session. This is by a gentleman named Professor Parmley years ago from Northwestern University, and I'll read it. He says, the profession of structural engineering can be characterized as the art of modeling materials we do not fully understand into shapes that we cannot really analyze, to withstand forces we cannot really assess in such a way that the public doesn't really suspect. And I think that is such a great quotation because there's a lot of truth in all those things. And I guess getting hung up in our own technology. So
Yeah.
I hope a lot of people will remember that quotation.
Excellent. Yeah, I think the AI thing is a really interesting one for me. It's definitely becoming much more prevalent. I've played around with it a little bit, not a lot, and not in a way that it would like design a whole building by any means, but just like help with little things here and there.
Uh-huh.
And it's really interesting to think about a future in which it can spit out solutions for
Right.
just like a whole building design.
Yeah.
That's pretty wild.
I thought 30 years ago, I was thinking of this stuff. I was involved with computers early on. I was thinking, I think someday I'll be able to talk to the computer and say, I'm thinking of a building. It's so wide, so high. It's IBC, seismic zone, whatever, and design it. That'll happen.
Crazy.
That'll happen. And let's hope we use our judgment and get it
Yeah.
AI started off on the right foot.
Yeah,
Okay?
yeah. Once we get that design back, hopefully the people looking at it take that gut check and
Yeah,
make sure it seems like it's right. So
right. Okay.
excellent. Well, thank you so much for sharing your valuable insights and all of your expertise with us today. It's been a pleasure having you on the show, and I really appreciate your time.
Yeah, well, I appreciate your comments. It was very nice, and good luck to you and your future endeavors.
Excellent. Thank you so much.
You bet.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and or questions. To leave them, please visit structuralengineeringchannel.com. There you'll find the summary of the key points discussed in today's episode, as well as links to any of the resources or websites mentioned during it. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcasts. Until next time, we wish you the best in all of your structural engineering endeavors.